We've talked about our four gas laws, and now we can combine them together such that we can solve for any of the four variables. We've talked about Amonton's law, P1 over T1 equals P2 over T2. We've talked about Charles's law, V1 over T1 equals V2 over T2. We've talked about Boyles's law, which is P1 times V1 equals P2 times V2. And we've talked about Avogadro's law, V1 over N1 equals V2 over N2. As we combine them together, we're going to look at where each of these variables is, whether it's in the numerator or the denominator. In both Amonton's law and Boyles's law, pressure is in the numerator. So in the combined gas law, pressure is in the numerator. Volume is in the numerator of Charles's law, Boyles's law, and Avogadro's law. So volume is in the numerator of the combined gas law. Moles is on the bottom, in the denominator of Avogadro's law. So it's in the denominator of the combined gas law. Temperature is in the denominator of both Amonton's and Charles's law, so it's in the denominator of the combined gas law. The combined gas law is P1 V1 over N1 T1 equals P2 V2 over N2 T2. The great thing about the combined gas law is that once you know the combined gas law, you can solve for any of the other gas laws just by canceling out the variables you don't need. Let's say we didn't need moles or temperature. We could cross off moles and temperature in the combined gas law, and we would be left with P1 V1 equals P2 V2, which is Boyles's law. Remember, Boyles's law assumes moles and temperature are held constant, allowing us to cross them out of the combined gas law. Here's an example of using the combined gas law. A scuba diver has a tank filled with 13.2 liters of air, and it's compressed to a pressure of 153 atmospheres. The water temperature is 27 degrees Celsius. What we want to find is how many liters of air can be delivered to the diver's lungs down in the ocean where the pressure is 3.13 atmospheres. Remember, at sea level, the pressure is about 1 atmosphere, so down deeper, with the water pressure on top, the pressure is increased. Notice it's not increased compared to the amount of pressure in the tank. The tank is very compressed. First, we need to identify our variables. P1, the initial pressure of air in the tank, is 153 atmospheres. V1, the volume of air in the tank, is 13.2 liters. And T1, which must be expressed in Kelvin, is 27 plus 273.15, which makes 300.15 Kelvin. The 2's are a little bit trickier to identify. They're going to be based on the conditions in the diver's lungs. P1 is pressure in the diver's lungs down deep in the ocean, so P1 is 3.13 atmospheres. T2, the temperature in the diver's lungs, is going to be body temperature, which is 37 degrees Celsius. We need to express it in Kelvin, so we take 37 degrees Celsius and add 273.15 to get 310.15 Kelvin. That body temperature of 37 degrees Celsius is one of the ones I mentioned in Chapter 1 that you should know. We're going to assume that none of the air escapes on the way from the tank to the diver's lungs, so N, which is moles, is constant. We're going to cross off N from both sides of our combined gas law. After crossing off N, we're left with P1 V1 over T1 equals P2 V2 over T2. Before we plug in values, we are going to want to rearrange the equation to get the variable we're trying to solve for isolated on one side of the equal sign. We want to find the volume of air that can be supplied to the diver's lungs. So V2 is what we are solving for. To get it by itself, we're going to need to multiply both sides by T2 and divide both sides by P2. Our rearranged equation becomes V2 equals P1 times V2 times T2 divided by T1 and divided by P2. Then we can just plug in our values. Again, we've made sure our temperature is in Kelvin, but the pressure and the volume we can leave as is. Make sure you put the values in the right place with the 1's and the 2's in the correct spot in the equation. When we do, we come out with 667 liters. With our combined gas law, we can't necessarily intuit what the answer will be because there are a lot of different variables, but we can just make sure that we're being consistent about how we do the problem. Again, if you struggle with algebra, go back and study it because it's going to be really important to be able to rearrange these equations properly.